Okay, now let's look at an interesting concept called the threshold voltage and what it is all about. Threshold voltage. Let's say we've been given a MOSFET that looks like this. It's an NMOS again. Oops. Well, I'm very bad at drawing, so kindly excuse me on that one. This is a MOSFET, and as you can see, we have the gate, the source, and the drain. The source is an N+ region, heavily doped. A drain is an again N+ region, heavily doped. I'm hoping that you're clear with the definitions of what doping and N+ and P regions and all these mean. Well, it's pretty simple. N+ means it has an abundance of electrons, and P means it has an abundance of holes. Holes are the absence of electrons. And well, this is a very typical MOSFET. Now let's look at what threshold voltage is all about. So under normal conditions, because this is a P substrate and everything except these N+ regions is P region, it'll have a lot of holes. And holes are given by this plus sign, and it'll have holes all over the place. Alright. Now suppose the drain is given a voltage of 0.1 volts constant and the source is grounded. For VG, the gate voltage, we start increasing from 0 volts and we go positive. What happens? When you give a positive voltage here, because of nature, similar charges repel each other and opposites attract, right? So because the gate voltage is positive, it will repel these holes from this area into this area. If holes are repelled from that area, what do you get? What are you left behind with are negatively charged ions, because they're now depleted of holes. Because they're depleted of holes, this area is now called the depletion region. Alright? And the number of negative ions here are balanced to mirror the positive voltage applied by VG. Now let's go still positive. Suppose we were at 0.2 or 0.3 volts. Then let's go to 0.5 volts. All these numbers are just for example. If we go to 0.5 volts, there's going to be more positive charges because of the gate's voltage here at the oxide silicon interface. And to mirror that, there's going to be more negative ions. Correct? Now, as I told you, N+ regions are abundant of electrons. But in a condition where the region is full of holes, the electrons from source will not travel to the drain. Why? If you think about it, because opposites attract, electrons are negatively charged and holes are positively charged, they will recombine to form stable elements or something. And we don't want that to happen because we need to ensure there is electron flow from the source to the drain. The electrons that leave the source just have to reach the drain. They cannot afford to recombine. If they recombine, we're losing current. Alright? And if there are holes, they're obviously going to recombine and we're going to lose current. So what we ensure is that the path from the source to the drain is full of negative ions. Because similar charges repel each other, we're sure they won't recombine with the electrons, and the electrons have a smooth transition from the source to the drain. And the voltage at which this happens, that means, suppose the electrons are standing at the door waiting for the coast to be clear for them to pass through, and they're sure, they're comfortable that there will be no recombination on their path. That voltage is called the threshold voltage. So when Vg approaches that positive value, when electrons start to move from the source to the drain, that is when we say Vg has reached the threshold voltage, which is called by VTH, which is denoted by VTH actually. In other definitions, it's also called the voltage at which the region here is as negative as the P substrate is positive. All right, when they equal those charges, we say that voltage of gate voltage is equal to the threshold voltage. And one more thing is, there are two terms that you'll always encounter, is depletion region and the inversion layer. Depletion region is when you deplete this region of all its holes. Inversion layer is when electrons start moving through the channel. That means in a otherwise positive area, you're having negative charges move from one place to the other. So you've inverted the polarity of that layer. That's why it's called the inversion layer. You'll keep encountering these two terms. That's why I thought I should let you know what they are. And that's about it. That's about it on the threshold voltage. Thanks.